As many students requested me that I have to show the pA2 value calculation, as many students faced problems with the pA2 value calculation in first sessional examination. So I thought of creating one video on the pA2 value calculation, so it will help all the students, not only of our college but of other colleges, to understand that how we have to calculate the pA2 value. Okay. So let's begin with it. So I have what I have done here, that I'll just go through the definition of the pA2 value. If you want to understand more of pA2 value, I have one pA2 value calculation, or that experiment video uploaded onto my YouTube channel. You can just check that out. So I have taken one data set uh, with which we are going to see how to calculate the pA2 value. Okay, and how to draw the graph. And I'm not actually going to draw the graph over here. I'm just going to tell you that what to do, what care should be taken while drawing the graph for the pA2 value. So how you are going to get the pA2 value from the graph, that I am going to show you. So pA2 value is defined as the negative logarithm of the molar concentration of antagonist, which is required to reduce the effect of double dose of agonist to that of a single dose in the absence of antagonist. So if you see a pA2 value is what information it gives is that it gives the information about potency of the antagonist. Okay, so if you have two or more antagonists, and you are supposed to compare them, and you are supposed to determine the relative potency of these antagonists with each other, pA2 value is very good tool to do that. Okay, so data set uh, such a data set will be given. Some data will be given to you, like for agonist drug, antagonist drug, stock solution concentrations will be given to you. Then molecular weight is given to you. Why molecular weight is given for the agonist and antagonist, that we are going to see in detail as we move forward. So also it will also be given to you that which dose you have to consider as a 2A. So if it is given, like in this case, if you see that 1.6 ml dose we are considering as 2A. So but obviously the a is nothing but the half of 2A. So A becomes 1.6 divided by 2, that is 0.8 ml. So depending on the data set, the given data, this may vary. Sometimes it may be given 3.2 ml or zero point 0.8 ml. So you have to just remember that whatever value the ml value, dose value is given to you, you have to just divide it by 2, you will get the a value. Okay, so in this case, the data which is given, that is for agonist drug, the stock solution concentration is 100 microgram per ml, and the molecular weight of the agonist drug is 169.03. Okay, so remember these values, as we are going to deal with them in detail in next few slides. So for antagonist drug, stock solution concentration is 10 microgram per ml, and molecular weight is 363.83. See, in here the stock solution concentration is given in micrograms. If it is given in milligrams, then what is to be done? Because we are going to convert these values, microgram or milligram values, into the molar concentration. So in that case, what is to be done, how to do the calculation, that we are going to see. Okay, so this is the data set. As you can see, this is for the agonist drug. So you have to calculate the concentration of agonist, then molar concentration of agonist, then you have to calculate the minus logarithm of molar concentration, then response height and percent response height. Okay, so these values you are supposed to calculate. So this is the data set for the antagonist. So you can see dose of antagonist is zero point 0.1 ml, 0.2 ml, 0.3 ml and 0.4 ml. So you have to calculate the concentration of antagonist accordingly. Then you have to calculate the molar concentration of antagonist. Then you have to calculate the minus logarithm of molar concentration of antagonist. Then the response height is given, various values you can see, and you have to calculate accordingly the percent response height. Okay, now as you can see, it is already given that we have to consider 1.6 ml dose response as the double dose, so that is 2a, and hence the a becomes 1.6 divided by 2, that is 0.8 ml. So do we have to calculate the concentration of agonist, molar concentration of agonist and so on, the values for all the values, dose values in the table? The answer is no. We don't have to calculate for all the other dose values, as we are supposed to consider only the two values, that is 1.6 ml and 0.8 ml. Other values, they are just the decoy. Okay, they are just given there to increase the work of the students, but in actuality you don't have to use these values, or there is no use of these values in any case, in anywhere. For graph also you don't require these values. For pD2 the situation is altogether different, but in case of antagonist you only require two values from the agonist dataset table, and that is 1.6 ml and the 0.8 ml as per the data which is given in this case. So I have taken only the two values over here. You can see that 0.8 ml and 1.6 ml. So what is to be done in this case? This 1.6 ml, as it is a 2a, we have to consider the response height of the 1.6 ml as the 100%. Okay, and based on that, so 34 millimeter response height we are considering is equivalent to the 100%. So we have to calculate the response height for the 0.8 ml. So 28 divided by 34 into 100. So whatever value we will get over here, you have to put it here as the percent response height. Okay, so in this case this value comes out to be 82.35 or something like that. Okay, so what we are supposed to calculate over here, what other parts we are supposed to calculate, that is we are supposed to calculate the concentration, we are supposed to calculate the molar concentration of the drug. So concentration, simple. How to calculate the concentration? Whatever the dose we have, that is we have two dose, that is 1.8 and 1.6, just multiply it with the 100, as the stock solution concentration is 100 microgram per ml. So multiply it with the 100, whatever value you will get, you have to put those values into the concentration of agonist. Okay, so how to calculate the molecular concentration? Simple. Whatever values you will get, the values that you will get, it is 80 and it is 160. Okay, so you have to, when you are supposed to when you are calculating the molar concentration, divide these values, the concentration values, by the molecular weight of the drug, the agonist drug. It is 169.03. Okay, and whatever value you will get is nothing but the molar concentration value. See, if it is microgram, then you don't have to multiply this with anything. Okay, but if it is a milligram value, that is stock solution value, if it is in the milligrams, then you have to multiply this with the 10 raised to minus 3. So why is it so? uh, because we are converting. I have shown that particular conversion of how to calculate the molar concentration and all, that I have shown that in under the pA2 calculation. For more reference, you can uh, refer to the book that is by Nirali Prakasham. Okay, so in their book they have given it, that how to calculate the, or how to convert the micro milligram concentration into the molar concentration values. Okay, so after doing all this calculation and taking the logarithm of the value which we get by dividing 80 divided by 169.03, the table becomes something like this. Okay, so you get these minus logarithm values. So these are molar concentration values, and this is the concentration of agonist, and this is the percent response height. Okay, so similarly we have to do for the antagonist. Okay, so here the antagonist concentration is 10 microgram per ml, and 4 doses of antagonist we are taking, that is zero point 0.1 ml, zero point 0.2 ml, 0.3 ml, and zero point 0.4 ml. So multiplying it with the 10, we get 1, 2, 3, 4. Okay, and as we are calculating the molar concentration, just divide this 1 divided by the molecular weight, that is 363.83. So whatever value you will get, something 0.00 value you will get, just take logarithm, sorry, logarithm of it, log of that particular value, it will give you the minus log. Okay, so when you take minus logarithm, whatever value you will get over here, you have to take only the log value, don't take minus log value. In your scientific calculator, take only the log value, it will come out to be in minus, it will have a minus sign to it, so minus minus gets plus. Okay, so all the values under the minus log m values, you will get all the plus values. Okay, so we will get, after doing all the calculation, we will get a table something like this: concentration of antagonist, molar concentration of antagonist, then minus logarithm of it. You see all the values over here, none of the values have the negative sign to it. Okay, so I forgot to tell about this percent response height. So see the response height over here of zero point 0.1, it is 32. So how come it became 32? I'll just show it to you. One sec. Okay, uh, that we have taken what is 100% corresponding dose is of the agonist, it is 1.6 ml. Okay, so corresponding height is 34 millimeter. Okay, so and we are considering it as 100%. So by definition you are supposed to take this concentration, a dose of antagonist with that of the 2A dose of the agonist. Okay, so what we are finding out, the concentration of antagonist which is required to reduce the dose of agonist, double the dose of agonist to that of a single dose of agonist in absence of antagonist. Okay, so you have to take a double dose of agonist, that is 1.6 ml, and you have to vary the dose of antagonist, that is 1.6 ml of agonist plus 0.1 ml of antagonist, 1.6 ml of agonist plus 0.2 ml of antagonist, and so on. Okay, so in presence of antagonist, the response height will decrease, obviously, because it is antagonist, it will bind to some of the receptors to which the agonist usually binds, and it will reduce the effect. So this 32 is the response we get when we give zero point 0.1 ml of the antagonist. So when you are calculating the percent response height over here, you have to, in all the cases, you have to consider 34, which is the maximum response height of agonist, as the denominator value. Okay, so don't consider 32 as the maximum response height. Okay, this is the usual mistakes the students make. So to avoid that, just remember you have to take maximum response height of the agonist as the denominator value. So 32 divided by 34 into 100, so this is 94.11. 29 divided by 34 into 100, so this is 85.29, and so on. Okay, so graph, how to draw the graph, that is on x-axis. The You have to give the label as the minus logarithm of m. Then on y-axis you have to take the percent response height as the label. So you have to remember one thing. We are finding out at what concentration of antagonist the effect of double dose of agonist becomes equivalent to effect of single dose. So in this case, the percent response height of single dose of agonist is 82.35. Remember this very thing, that this value, that is 82.35, it will vary depending on the data set given. It will never be constant. Okay, so in this case what we are supposed to do, we have to interpolate this value, that is 82.35, from the y-axis to the base fit line that we have drawn, and from once it reaches to that base fit line, we are supposed to extrapolate it onto the x-axis. So whatever x-axis value we will get, it is nothing but the pA2 value. Okay, so I'll just draw the graph, a simple graph, so that you will get idea what exactly I am talking about. Okay, so this is a blank page. This is x-axis and y-axis we have drawn. This is x-axis, this is y-axis, and this is percent response height over here. Okay, and this is minus log m. Okay, so you which points you will plot over here, you will plot points of minus logarithm m points of the antagonist and percent response height of the antagonist only, antagonist tables only. The agonist table, whatever values we have calculated, what to do with that I'll just show you. So suppose we have plotted the points and we have got some line like this. Okay, so what you are supposed to do over here, you are supposed to interpolate the corresponding response height of the percent response height of the a value, that is it is 82.35. so you have, this is suppose where we the 82.35 lies. Okay, so you have to interpolate, one second, you have to interpolate over here. So from here you have to extrapolate downwards. Okay, so whatever value you will get here, it is nothing but the pA2 value. Okay, it is pA2 value. You don't have to take the anti-log of this particular value. Whatever value you will get over here, it is nothing but the pA2 value, and the same value you have to report as the result. Okay, so in conclusion, whatever you can write, if there are more than two antagonists, you can write actual conclusion that potency of this antagonist is more than this and something like that. Okay, so I hope you got to know that I tried to make it shorter, but still it is almost 20 minutes video. I hope you will see it to the last, and that's all. I hope you got the points. If you have any queries, any doubts, then you can post your questions in the comments below, and I will try to answer it from my side. Okay, So thank you all for listening carefully. I hope you get it, and I hope you will do well in your exams, understanding what I have just done over here. Okay, so thank you.